Welcome to Combined Heat and Power webinar for wastewater treatment plants presented by California Energy Commission and Pacific Department of Energy CHP TAP. We have a full agenda today with very diverse stakeholders from many states actually. So we're covering a rather wide range of wastewater treatment plant combined heat and power topics. And we would like to follow up possibly with another more in-depth webinar. And there will be an evaluation that we would really appreciate your feedback on after the webinar when you receive an email. This is an outline of today's presentation. We're going to review some of the goals and programs. I'm going to introduce my Department of Energy Technical Assistance Partnership Services. We're going to talk about a lot of different wastewater treatment CHP related topics, as you can see here. And we have a great panel with some folks that operate the plants that will share their experience as well. So a quick introduction, my name is Gene Kogan. I'll be moderating today, presenting, and I'm the Assistant Director at the Pacific DOE CHP Technical Assistance Partnership at Center of Sustainable Energy, which is a mission-driven nonprofit organization of about 100 employees, headquartered in San Diego with offices in LA and San Francisco. We specialize in a variety of clean energy areas with focus on transportation, renewable energy, and energy efficiency, and implement programs and initiatives for and in partnership with state, regional, local policymakers and regulators, businesses and utilities, and research institutions. Let me introduce our speakers. We'll start off with Grant Mack, who currently serves as Energy Policy Advisor to Chair Robert Weisenmiller of the California Energy Commission. He advises the chair on portfolio of energy policy matters, including combined heat and power. He's also involved with energy research and development collaboration with U.S. Department of Energy and Advanced Research Project Agency. Also involved with issues of energy and climate change policies. Next, let me introduce Keith Davidson, who is the president of DE Solutions, and a consulting and engineering firm serving the distributed energy markets. Keith is part of my DOE Pacific CHP team as well, has more than 25 years of experience in energy and environmental technology development, project management, feasibility studies, and different engineering and economic analysis and market development. That will be followed by Eric Jorgensen, who's a senior PE civil engineer working capital improvement project group for Eastern Municipal Water District. He's responsible for capital improvement projects at 4 different reclamation facilities and has over 25 years of experience in the industry, both private consulting and public agencies with wastewater. And finally, let me introduce Chuck Rogers, who is a superintendent of City of Thousand Oaks Hill Canyon Wastewater Treatment Plant, and he's a frequent speaker on issues of wastewater treatment plant optimization and renewable energy generation. Chuck has 34 years in the industry, so we have a lot of knowledge today for you. Now, at this point, I'd like to welcome Grant Mack, and he'll provide us a brief overview of California Energy Commission and their CHP efforts. Grant?
Great. Thank you, Gene, and for the introduction. And thank you, everyone, for joining us this morning to discuss combined heat and power in California's wastewater treatment plants. Before getting started, I would like to first thank the Pacific Region Technical Assistance Partnership, funded by the USD, for organizing this webinar in collaboration with the California Energy Commission. Next slide, please. So for those of you unfamiliar with the California Energy Commission, we are a state agency that was established in 1974, and we serve as the state's primary energy policy and planning agency. We are guided by 7 core responsibilities that I'll run through really quick. These include forecasting electricity and natural gas demand to assist with infrastructure planning purposes, developing the state's appliance and building energy efficiency standards. We also support energy research and development activities in energy efficiency, advanced and clean generation, and systems integration. This core responsibility is probably going to be of interest to most of the folks on the line, and I'll discuss a little bit later. We also administer a variety of renewable energy resource development programs, such as the New Solar Homes Partnership Program. We fund alternative renewable fuel infrastructure and vehicles, certified power plants 50 megawatts and larger, and finally, we plan for and direct the state's response to energy emergencies. Next slide, please. So combined heat and power in California is recognized as a preferred energy resource due to its many benefits, and these include some of the following: fuel efficiency, potential for reduced greenhouse gas emissions, avoided losses from transmission distribution, grid support, increased reliability for critical facilities such as wastewater treatment plants, and of course economic benefits for energy-intensive industries. Currently, we have 3 state policy goals that are really driving the development of new CHP here in California. These include Governor Brown's Clean Energy Jobs Plan, which calls for an additional 6,500 megawatts of new CHP capacity by 2030. We also have the California Air Resources Board original climate change scoping plan targets that sets a goal of 4,000 megawatts of additional CHP capacity by 2020, in addition to a GHG reduction goal of 6.7 million metric tons of CO2 equivalents. And then finally, we have the California Public Utilities Commission Qualifying Facilities and CHP Program Agreement. This basically mandates that California's 3 largest electric investor-owned utilities, PG&E, Southern California Edison, and San Diego Gas and Electric, procure a combined total of 3,000 megawatts of excess and or exported electricity from CHP facilities and achieve a GHG reduction goal of 4.8 million metric tons of CO2 equivalent, all by 2020. Next slide. So there are numerous programs and opportunities in California that support the development of new combined heat and power resources. Perhaps the most immediate opportunity for wastewater treatment plants in Southern California specifically are those located within Orange County and San Diego County. This is mainly due to the closure of over 2,200 megawatts of capacity that is offline due to the closure of the San Onofre Nuclear Generation Station. There are procurement opportunities available through many of the utilities down there, but specifically Southern California Edison and San Diego Gas and Electric, either through bilateral contract negotiations or competitive solicitation processes through their standard request for offers. There's also our Energy Research and Development and Demonstration Program that we as the Energy Commission administer that I think many folks will be interested in. And basically our program funds a variety of innovative CHP projects. These are mainly focused on reducing and increasing market penetration of some of these new technologies, and it could include highly efficient systems, low emission control technology, use of renewable fuel, and of course fuel and flexible systems. I highly suggest that those on the line definitely go to our website at energy.ca.gov/research, free to find kind of upcoming and current solicitation opportunities for these type of activities. Some of the most notable combined heat programs here in California include our AB 1613 program, also known as the Waste Heat and Carbon Emissions Feed-in Tariff. This is a standard contract and fixed price for any exported generation from CHP 20 megawatts and below, and you can find these options through your investor-owned utility. We also have the SB 1122 Bioenergy Feed-in Tariff. This is also a standard contract and fixed price for excess generation, specifically bioenergy projects, but it also includes CHP fueled by biogas, and this is for projects 3 megawatts and below. Currently, the IOUs must procure a total of roughly 250 megawatts of generating capacity from bioenergy projects that commence operation post-June 1st, 2013. It's worth noting that of this 250 megawatts, 110 megawatts has been set aside specifically for bioenergy projects at wastewater treatment plants. Currently, the CPUC is working on their decision, which hopefully will be released sometime this fall, and this will allow the IOUs to move forward with developing and administering the program in their territories. Finally, a program that most of you are probably familiar with is the SelfGeneration Incentive Program. This is an upfront and performance-based incentives for CHP generation up to 3 megawatts. It's probably worth noting that SCHIP funding was recently extended to December 31st, 2019 with the recent passage of the 2014-2015 budget trailer bills, and the administration of this program will continue until 2021. That's it for me, and if you have any questions, I look forward to them towards the end. Thank you.
Thank you, Grant. So right now we're going to do a quick 2-question poll. So I'll ask you all to please respond, and we'll share the results with you. The first question is, do you have combined heat and power plant at your wastewater treatment plant? Please vote now. All right, so we're going to close the first question and show it right now. And it looks like 35% of today's attendees have CHP at their wastewater treatment site. So we welcome everyone else and hope that you can grow your CHP system after this webinar. The next question is, why are you joining us today? So you should see it appear right now, and please start your votes. So we're going to display the results now, and it looks like 67% of you joined us today to learn about recent CHP trends and drivers, and 16% are just interested in general overview of CHP. Thank you very much for participating in our poll. As CHP is an efficient and economic and definitely energy security solution. And next slide, thank you. So the president has a 40 gigawatt goal by 2020 for new CHP, and combined heat and power TAPs, or technical assistance partnerships, are critical components of achieving that goal. We are the Department of Energy's regional combined heat and power experts. We provide fact-based, unbiased information on CHP, whether it's technologies, project development, or a slew of issues we'll be discussing today. We are vendor, fuel, and technology neutral. My partnership specifically is the Pacific, and you might have done business with technical assistance partnerships before. They were called Clean Energy Application Centers prior. And my partnership, the Pacific, covers California, Nevada, and Hawaii. And my team includes myself here at Center for Sustainable Energy, as well as DE Solutions, which is Keith Davidson, who will be presenting today. And also we have Energy and Environmental Economics. So our key activities are market opportunity analysis, supporting CHP market, and then education and outreach, which is why we have this webinar with California Energy Commission today. And perhaps of most interest to all of you, and we hope most participation from all of you, from technical assistance services that my program provides to end users and stakeholders to help them consider CHP, waste heat to power, or district energy with CHP in their facility, to help them through development process and initial screening to installation. Here are the other 6 technical assistance partnerships. There's a total of 7 with the contact information. So let's start off with what is combined heat and power. It's basically a form of distributed generation. It's an integrated system, typically located at your facility or close by, and it provides at least a portion of your electrical base load, and it's important to use the thermal energy for space cooling, heating, or process heating and cooling, and dehumidification. Excuse me. As you can see from the diagram, it's an extremely efficient way to create electricity and heat at the same time. Next slide, please. In addition to efficiency, which obviously lowers your operating costs and reduces emissions, there's an important component there to increase your energy reliability and enhance your power quality with CHP. And of course, on-site generation reduces grid congestion and avoids distribution costs. There are many drivers for doing CHP at wastewater treatment plants. Obviously, desire to reduce energy costs. Resiliency of critical infrastructure is important. Many folks do it for reliability or sometimes as part of their facility upgrades. And there are available incentives that are coming up in some of the slides. Wastewater treatment plants and CHP is nothing new. United States has 167 facilities generating 565 megawatts. In California, as you can see, is about half of that generation. And when we talk about CHP, the prime movers in California, as you can see, reciprocating engines, microturbines, fuel cells, and some turbines. Go ahead. So, you know, the good rule of thumb when considering CHP at wastewater treatment plant is to utilize your anaerobic digestion for biogas. And the fourth bullet here is perhaps of the most interest, that for each 4.5 MGD processed by the plant with anaerobic digestion, you can generate about 100 kilowatts of electricity. So what makes a great anaerobic digestion CHP project? Well, it's great when you can maximize revenue streams. Using Codigestion, you can flip those economics positive. Some Codigestion feedstocks are among amazing producers of biogas, and we can't understress enough that proper design for climate zone and technology choice matches solid content of the feedstock. You really have to understand that. Scrubbing the biogas is important, and again, maximum recovery of heat for that efficiency, and of course, strong operational maintenance support. As far as design lessons, you have to make sure that all your parts of the systems are properly sized. Don't oversize the genset compared to biogas supply. Biogas, not thermal load or electric load, governs sizing. So you got to know your biogas. Natural gas can supplement biogas. It stabilizes the gas flow to genset. It helps match your genset size to critical load requirements, and it can support digester temperature requirements. Again, you have to aggressively recover the waste heat. Consider pasteurization of biosolids, and biogas scrubbing is a high priority. Don't scrimp there on the costs. And consider the system design implications of codigestion early on. Biogas treatment and conditioning is another key issue if you want a long-term system life. There are separate steps that you need for proper order of removal. Next slide, please. As far as environmental considerations, consider air quality, water quality, how you're going to manage your biosolids, and codigestion impacts on your overall system. Beyond the waste, just recycling organic materials and avoiding landfill is great. You'll have one of our speakers talking about that in a few moments. As far as the economics, anaerobic digestion, you can maximize co-products. There's 7 potential revenue streams. Obviously, you're generating power. Then green and renewable power adders, carbon credits, pasteurizing biosolids for sales and field application, and moisture does add value. Tipping fee for fog and food processor waste. Co-digestion increases your biogas production, and again, waste heat for digester buildings and small district energy systems is another source of potential revenue. Add-on systems do cost money, but also add revenue and reduce other costs. There are 2 opportunities to improve your CHP economics. There's a 10% federal investment tax credit, and as my next slides will show, we'll get into self-generation incentive program. So what is self-generation incentive program? That is a program that provides cash incentives for installation of clean and efficient distributed generation technologies on a customer side of the utility meter. It's a ratepayer funded program, like Grant mentioned earlier, from CPUC. It's one of the longest running programs in the country, and incentivized distributed generation since 2001, and it just got extended. The primary goal of SGIP is to reduce statewide greenhouse gas emissions. If it's available to electrical and gas customers of major owned utilities in California. And this is an interesting slide because it shows you the actual incentive. And as the red arrow points to biogas, that's an adder of $1.62 on top of those 46 cents, for example, in the middle columns for microturbine or IC engines. So that's a $2.08 incentive per watt. Next slide, please. Parameters for success. If you're going to implement CHP at your site, you really need to have a champion that is really going to embrace it and be passionate about it. It's very important to engage your local utility early and interact with them and explain how you're going to do what you're going to do and understand what their requirements are. System design, you need to collaborate with us. My program can help you with that. If you have any kind of technical questions, we have engineers with many years of experience standing by and ready to answer those questions from you. You do need to contact us with any of those technical issues. We're happy to help you. That's what we're here for. System design is also important to have experienced project developer. Again, bioscrubbing is a key balance of plant component. On operation and maintenance, it requires personnel, or you have to have a third party with appropriate experience and training. Same thing with biogas. Make sure you get somebody with experience with scrubbing issues and maintenance. So part of this presentation and a follow-up is you will receive some case study and project profiles on some of the plants that we host on Department of Energy deployment website. And We have different projects we highlight and showcase for combined heat and power. You can download the top 3 right now on that website, and the bottom 3 we're developing right now. And those are actually the plants that we have speakers from today that you'll hear from in a few moments. They'll come your way as well. And if you have a great CHP story at your plant, I would like to hear from you and discuss perhaps we can create a project profile for your site to showcase how CHP is helping you. So in conclusion and next steps, it's an economic advantage. Make your own power for on-site, use it or sell it. Perhaps a long-term power purchase agreement can help you. Quality design is essential. Use the biogas effectively, maximize your heat recovery. Energy independence is important for wastewater treatment plants with critical facility load requirements. Support your local utility grid with demand response by participating in their programs, utilizing your CHP. The CHP TAP is here to help again with the next steps. We can do everything from qualify your site and give you a high-level go, no-go decision of growing your CHP or adding your CHP to your site is feasible. And then we provide a slew of different technical assistance to help you with your CHP project. So next, Keith Davidson will present on South Coast Air Quality Management District Rule 1110.2, and he will review how Orange County is getting their CHP plant ready for compliance on behalf of Lisa Rothbard. Keith?
Thank you, Gene. For starters, I thought I'd just provide a little background on South Coast Air Quality Management District and Rule 1110.2, which in January of 2016 will ratchet down emission requirements for biogas engines, which include those from wastewater treatment plants. And I think everybody appreciates that South Coast is considered an extreme non-attainment area for ozone by the EPA. Interesting tidbit that some of you may not know is that South Coast Air Quality Management District is but one of 35 air districts in California, but it's a fairly sizable one and is home to about 17 million Californians, which represent about 50% of the population in the state. So it's a very, very significant air quality district. And they're under the gun by the Environmental Protection Agency to reduce NOx emissions by 65% over the next 10 years, which is an extreme challenge in my opinion, given all the progress that they've already accomplished over the past 20 or 30 years. And Rule 1110.2 addresses stationary and portable engines in excess of 50 horsepower, but in particular, the one rule that kicks in January 2016 is specific to biogas engines. Next slide, please. This just kind of highlights the changes. The NOx requirements ratchet down from between 36 and 45 parts per million today to 11 parts per million in 2016, and you've got some also significant reductions in VOCs and CO that are happening as well. And in the basin, this is off of a South Coast presentation. There are 55 biogas engines in operation. Next. So this new engine rule will create a new challenge for engine systems, and I think in general require a new emphasis on biogas conditioning for practically all solutions at wastewater plants. And in the engine category, you've got two options: one with lean burn engine that would incorporate selective catalytic reduction in an oxidation catalyst, or a rich burn engine, which is more common in the smaller sizes, that would incorporate a three-way catalyst like is common in automobiles, with a premium air-fuel ratio controller. And then you've got microturbines and fuel cells. Their regulations haven't changed, but again, they also need to have biogas conditioning systems at the front end of the process. Next slide. What I thought I'd do now is talk about an example of a solution that's being being implemented by Orange County Sanitation District, and I put this sanitation district in the class of large wastewater treatment plants. And following my talk, Eric Jorgensen with Eastern Municipal Water District will address some of the issues and solutions that they're considering for small and medium-sized wastewater treatment plants. So Orange County Sand, 207 million gallons a day, 2.5 million people, and 2 significant treatment plants. And we want to thank Lisa Rothbart, who couldn't join us on the call today. She's on vacation, but for providing us the material to tell you a short version of her story. Next. So you can see in the 2 plants, one in Fountain Valley, one in Huntington Beach, they've got large lean burn engines in both sites with a total nameplate capacity of 7.5 megawatts at Fountain Valley and 16 megawatts at Huntington Beach, with a combined digester throughput of 1.4 billion cubic feet in 2013. These systems have been in operation since 1994. It's a $25 million project cost, and you can see that the plant has paid for itself in savings more than twice-fold, probably threefold since it was put in. Next. So the solution for Rule 1110.2 2016, they implemented a demonstration project about 3 years ago on one of their lean burn engines, Cooper Bessemer, 2.5 megawatt engine with heat recovery. And requirement as part of the permit is for engines of that size is a continuous emission monitoring system, which came in handy for this demonstration project because it continuously records NOx and CO emissions, which made record keeping and data acquisition fairly easy for them. Next, please. The solution was a pretreatment system that consisted of a single carbon bed, 9,900 pounds of media capacity, with a selective catalytic reduction system and an oxidation catalyst for CO and VOC reduction. And it just a picture of it, and it kind of shows where the urea injection occurs and points out where the SCR and the oxidation catalyst are. Next, please. This is a summary slide that shows the results of their demonstration test, which was the first year of operation, and the subsequent 2 years of operation, and how things have performed. The original catalysts are in place. There hasn't been a catalyst change to my knowledge. And on the right, you can see where the Rule 1110.2 requires you to be, and you can see that after 1 year and after 3 years, they've been these are average values, so there's some deviation, but if for the most part, they've been considerably below the compliance targets or requirements that are going to be set by AQMD in 2016, and have done well enough that they've decided to implement this solution on the other 7 of their engines. They've awarded the construction contract in April of this year, and a notice to proceed was issued a couple of months ago. And again, Lisa Rothbart is the what has been our point of contact at Orange County Sand on this project, and her contact information is provided on this slide. Thank you very much.
Thank you, Keith. Quick reminder to the audience to please send in your questions using the question prompt in your webinar toolbar. We will make sure to address questions at the end of the presentation. And moving along, I would like to ask our next presenter, Eric Jorgensen, to, before he dives into his slide deck, briefly describe, Eric, why don't you tell us what is the reason for CHP at your site?
Gene, thank you for having me come here to speak, and thank you to the CHP Technical Assistance Conference and also to U.S. Department of Energy. Gene, to address your question, we actually have three drivers that we look at. The primary driver is return on investment for our ratepayers, and we have an obligation to do things that benefit our ratepayers, and CHP projects are generally items that return value to the ratepayer. The second issue is sustainability and reliability of our energy portfolio. And in the case of providing CHP with biogas, that's a gas that we produce on site that puts our energy system under our control. And the third driver is that we have resources that are produced as byproducts of wastewater treatment that have value and basically to return value from those resources. So the topic I wanted to discuss today is about our engines and our considerations of maintaining engine operation at treatment plants with Rule 1110.2. Just an overview of EMWD. EMWD is located in Southern California in the western part of Riverside County. We service about a population of about 768,000 people. We are an area that's still growing. We're only at 45% of ultimate build-out. We offer water, wastewater, and recycled water services, and we have 7 cities plus unincorporated areas of Riverside County within our service district. We operate 4 regional water reclamation facilities, treating about 45 million gallons a day total. In comparison to Orange County, obviously, they treat quite a bit more, have fewer plants, so the scale and intensity of their plants are larger than ours. And we represent a smaller scale of operation, but probably representative of a majority of our industry. Next slide. Our efforts on the sustainable energy initiatives have been focused on, at the treatment plants, we have a history of using IC engines, and we recover heat, power, and we provide pumping, drive shaft power for our pumps. We have biogas-fired boilers, and we have fuel cells at 2 of our facilities producing about 1.5 megawatts of electricity plus heat. We also have plans to install solar power, about a total quantity of about 5 megawatts across our district. District-wide, we use IC engines quite a bit, and they are used for power pumping operations. We have about 56 engines providing an equivalent of 14 megawatts of power, and those are continuous duty. In addition to that, we also have standby generation capacity coming from about 79 installations, providing about 28 megawatts of power on demand as backup power. We operate microturbines. We have an absorption chiller at our administrative center, and we also have an existing solar panel system at our administrative center providing about 0.5 megawatts of power. Next slide. The challenge to us with IC engines is to comply with 1110.2. At 2 of our facilities, we have fuel cells, and we are fairly confident that we have a way to continue to use biogas without concerns about 1110.2. At our Temecula Valley and San Jacinto facilities, we require a solution because it could have an immediate impact on us in continuing operations with engines. Our strategy is to evaluate multiple viable options. We have been performing a trial with KnoxTech, which has been in progress for the past couple of years. We have a planned trial with another emission control technology called Codigestion that's going to be implemented shortly. One of the things that we're not considering is an SCR, and primarily because most of our biogas engines are rich burn engines, and in the scale of magnitude of our operations, we feel that does not necessarily match our needs and the way we operate. Next slide. So our criteria for success, as Keith Davidson mentioned, is maintaining compliance with 1110.2, maintaining NOx below 11 ppm, and CO below 250. But beyond that, we must be able to demonstrate consistent and enduring results with regards to emission control. And we also need to be economical, and that's the primary driver for us, again, is to provide return to our ratepayers. Next slide. Next slide, please. Thank you. KnoxTech is a emission control device. If we can go back one slide, please. Which essentially is a reaction chamber similar to an SCR. It takes in urea. It also takes in additional fuel. It attempts to pyrolyze urea and provide ammonia for reduction of NOx. This type of system supposedly does not require any biogas pretreatment, and that's one of the attractiveness of it. Next slide. We've had a trial installation at a pump station at our Mills pump station, which has been a lean burn engine, and as you can see, the device is fairly large, the reactor is fairly large, and it's really designed for connecting to multiple engines and to provide emission control for exhaust from these engines. In this particular case, this is at a pump station. The gas source is natural gas. We had some challenges during this trial. If you go to the next slide, please. You see that we had to modify the equipment by installing an EGR, and we believe is that because it was a lean burn engine on natural gas, then trying to achieve conditions in the reactor that were necessary for the emission control, but this was a pretty big challenge. Next slide. So our experience at Mills is that with the natural gas on a lean burn engine, it wasn't plug and play as expected. The initial testing was not successful, and AMWD staff had to provide a lot of assistance with the startup. Ultimately, we did show that it could comply with natural gas engines, but the control was very difficult, and it was not what we would consider reliable at this point in time. We do have another trial planned that's just completed installation. It's going to focus on biogas using a rich burn engine at one of our treatment plants. And we plan to begin this trial in early August. Next slide. So with this trial, we've completed installation in July. We have startup commissioning starting next month, and then we plan to complete this trial in early 2015. Next slide. But that's not the only pilot trial that we have in process. We have done an analog trial with a different emission control system provided by Codigestion. And as you can see in this diagram, you see an exhaust line coming from a rich burn, a natural gas-fired engine at a pump station. And essentially, the Codigestion patented process is two conventional catalysts in series separated by a heat exchanger. Essentially, they're removing CO in the first catalyst. They cool the exhaust, and then they remove the NOx and the polishing catalyst that follows. Next slide, please. As you can see, the results that we obtained in the trial were extremely promising. We were very excited about this for rich burn natural gas-fired engines at remote locations, and the results have encouraged us to now consider that how this could be implemented with a biogas-fired engine at one of our treatment plants. Next slide. So when you consider what would happen at the treatment plant, we have anaerobic digesters. We have to go through some type of digester gas conditioning, which is an additional step that KnoxTech would not require. You consume the gas on an engine and then proceed through the emission control device. And you can see just a general layout of what that process will look like. But one of the things that the district is confident of is that we really understand gas conditioning, and our experience with fuel cells has taught us quite a bit about how to precondition gas. We believe this trial will be very successful. Next slide. So this trial has just taken off in the past couple of months. We've got our plan to issue a purchase order for the Codigestion system in August, complete modifications of digester gas piping, and do the installation on the exhaust system and the engine by November. We also will be incorporating our hot water loop into this system, and then we'll do startup and conditioning in roughly January of 2015. We feel it'll take us about 9 months to continuously run this system, demonstrating compliance with 1110.2 to assure us that with conventional catalysts that we're able to get an economic return on the investment. The assumption is if a conventional catalyst can last for a year of operation, we would be in very good shape. Next slide. Thanks again to the U.S. Department of Energy and the Technical Assistance Alliance partnership. I'm Eric Jorgensen with Eastern Municipal Water District, and Gene, I guess I'll turn it back to you.
Well, thank you very much, Eric. And now we'll move to our final speaker. We do have a lot of questions regarding receiving the slide deck. You will receive the slide deck in email, and also I'll remind everyone to please post your questions into the toolbar, and we'll get to those at the end. So now I would like to welcome Chuck Rogers. And Chuck, I have the same question for you. What's the reason for CHP at your site?
Well, I think Eric gave as good an explanation as he could. Of course, all the financial issues, the environmental issues as well. Plus, I just think it's a great business practice. I think if you have anaerobic digesters and you're flaring gas, you should be doing CHP. It's that simple. Hill Canyon Wastewater Treatment Plant, our energy program, we'll just jump right into that. We're a medium-sized wastewater treatment plant, and I think you're going to see a far different perspective. What smaller people have to do, smaller wastewater treatment plants to, achieve the type of things that we're doing. First off is the focus on conservation, optimization, and renewable energy generation being third. And I really, truly believe in this as we have worked our way to 100% here at the facility. It's been a combination of all those events. We've never stopped trying to optimize our wastewater treatment plant. And by doing that, we simply made our cogeneration even better. We have 2 power purchase agreements at the facility for both solar and cogeneration. You see some nice pictures of it. See that excellent engine there, the gas core engine. We essentially have paid nothing for all of this. $0 have gone into it from the city. We have 2 private operators of the facilities and owners, and it's a situation that works out beautifully for the city of Thousand Oaks. I have 25 employees. We don't have a core competency in cogeneration, and I don't think it's an easy deal anymore, and I think Eric got right to it. These are very complex systems and require a lot of care, and we're in the wastewater treatment business. So 100% of our energy use at the facility is now provided by on-site generation. That's kind of a difficult target to hit, because it's very easy to be a little over or a little under on it, but it is what it is. It was an aggressive goal, and it took us 4 years to achieve, and it had its challenges. Next slide, please. The road to 100% renewable, the solar gave us 15%. Our initial cogeneration installation gave us 50%. And, in order to get to that 100%, again, we're looking at optimization. We're looking at conservation, but we also realized in order to get that, we're going to have to increase our cogeneration abilities. So to get that 35%, we started importing waste in here: fog, beer waste, yogurt waste, frappuccino, orange juice. We've tried all kinds of different things. Next slide, please. And the economics of it are, we receive a tipping fee for all the waste received. We in turn, these waste create more gas and electricity. And, typically it's half the price of the cogeneration that we pay the, private owner that we would be paying Southern California Edison, sometimes less. And again, all that responsibility was on the owner to construct and operate those facilities. Obviously, when we're receiving all these different wastes, we're creating more gas, which in turn gives us that ability to create more electricity. Next slide, please. This road to 100%, if it was easy, everybody would be doing it. Fog is a difficult material. Sometimes it's kind of in our business almost romanticized, that if you bring this in and magically put it in your digesters, everything's going to be great. It's nasty stuff. It stinks. It's at times contaminated with a lot of junk that come from restaurants. It has variable BTU value. And if you're going to do this, you can't ignore the fact that you're going to use your own labor costs to run the business. And by all means, it is a business, and it requires you to be business-like. Next slide, please. An alternative plan for this, and I've seen this at other facilities, is you can set the goal as 100% and continue to work on conservation optimization and run your digesters and cogeneration system as efficiently as possible. I think a decent rule is 50% renewable energy generation if you have these anaerobic digesters, but getting to 100%, I would say, a different approach than mine is, even though I was working on those type of things, is, I didn't leave myself maybe enough buffer. So I added enough cogeneration, so I've got that taken care of. And I find myself in a position today where, I can create 20%, 30% more electricity at any given moment because of the extra gas I've created. So there's kind of a, hopefully learn from my lessons on that one. Next slide, please. We currently create a couple 100,000 cubic feet more gas than necessary to meet our 100% energy load, and we do have barriers to exporting electricity beyond what is needed to run the facility. Gene, you made all the sense in the world. You got to work with your utility and really know what's going on with this. I do think the extra gas certainly gives us another private-public partnership opportunity to convert that into some fuel, possibly. Like I said, at Hill Canyon, we really don't have that kind of demand for that, but we're looking to see if we could find yet another partnership going here, because we have demonstrated for some time that we can create this extra gas. Next slide, please. The good news is the public loves this stuff. It makes everybody happy, and our staff, while not operating it, continues to be challenged. Certainly, putting together the fog waste receiving business was challenging, and I think it made us better operators of our wastewater treatment plant because of that. I'm a strong advocate of these PPAs, both on solar and the cogen side. And the reason why, is with a small staff, you really need highly skilled technical people. And I think it's easier for an Orange County or Eastern Municipal to have a larger staff to develop that core competency, whereas for smaller wastewater treatment plants, not so easy. This is very technical stuff. And I know we're very technical people, but, my job is to treat wastewater here, to deal with biosolids and other matters as well. So it's, I'd rather leave this to somebody that's an expert. And I think by doing that, we become a national model for entrepreneurship and public-private partnerships. Next slide, please. I want to thank everybody. I also want to say I left out one technical detail. We use the heat from the cogeneration here for our admin building, of course, our digesters. And we're also launching on a transformative biosolids project in which we hope we can use the additional heat down there to deal with that particular issue. But, thank you, all of you, taxpayers, California Energy Commission, Department of Energy, and certainly everybody at the City of Thousand Oaks. I wish you the best with your energy program. Please feel free to give me a call. I certainly could share all my mistakes that I've made with you and give you some good recommendations on it. But, if you don't have CHP today, I just think it's an excellent deal, even if everybody wasn't throwing money at you to put it in. If you don't have a CHP system, I urge you to put one in. If you've got an older one that's not running optimally, you can come in with a PPA and you can get a brand new system there, let somebody else run it, and really optimize the energy that you can create at your treatment plant. Anyway, thank you all very much. I wish the best to you, and hope you have some questions. Thanks. Bye.
Thank you very much, Chuck. Here's Chuck's contact information. So at this point, I'd like to present to you how we can help. Chuck mentioned this is technical stuff, and whether you have staff on hand or not, the Pacific DOE CHP partnership is here to help, and here's how we can do it. Initially, we typically start out with a screening and basically a quick analysis to figure out if CHP makes sense at your site. That is a federally funded service, no cost to you, to figure out, does CHP make sense, kind of a high-level look, and it really doesn't take much of your staff time, maybe a couple of hours of engaging with our staff. Next, if it does make sense, our staff can do feasibility analysis for you. There is a partial cost to that, or your engineers can do it, or vendors and suppliers and equipment manufacturers can do it for you as well. and that is a more in-depth engineering study at your facility to see what is feasible and what makes sense for you as far as CHP system. And then if we didn't do the feasibility analysis and you have proposals, the third box on investment grade analysis, if you have proposals already in front of you, we are happy to do a third-party review of those. Again, federally funded service, no cost to you. We're here to help and to compare different proposals for you. Take a look at it, another set of engineering eyes, and present you a report identifying key issues in proposals, and make sure that you're well informed with all the issues for CHP and the technology and the design you're considering. And finally, on the back end, we're happy to provide technical assistance. Again, we're here to grow CHP and make sure that you have the technical support you need. We're happy to review specifications or help you with bids and some operational analysis. And as I mentioned before, we're also creating project profiles to showcase CHP projects so that potentially new users or folks who are looking to grow or bring their CHP back online can see what's being done out there, and I'll be happy to do that for you as well. Next slide, please. So as next steps, I'd like to ask you all to please contact me for assistance. The reason California Energy Commission and Pacific DOE TAP put together this webinar for you is to hopefully engage you on your next CHP project, to make sure that if you have technical questions, you please bring them to us. We'll be happy to answer them for you. And whether my message to the vendors and the engineers is basically, if you have proposals or you're working with customers and on a CHP system, then you can involve us, and if our technical assistance and Department of Energy reports can help the customer make that decision after knowing that someone else looked at it, then we can help the vendors. And if you're one of the users, if you're considering replacing your equipment or incorporating some of the new ideas like Codigestion you heard today, and looking to increase the size of your CHP system, please contact us as well. If you have design questions, we're here to help. My contact information is on the screen right now. And next. So this brings us to questions. And please use the questions box in the toolbar. The question is, what was the impact on your utility connection tariff, and did you have to negotiate something with the utility? So I guess the question is about interconnection and tariffs.
Yeah, that was a little painful. We have net metering, and if I could just tell you, this took place over a period of the last 7 years. When we had the solar, you could just figure out the energy balance. We're using about 700 kW here, so we had to have, an interconnect agreement with them. So we're on the net metering, which makes it nice, because I would never have been able to get the cogen up any higher than I could have, or I would have to really have a strange kind of operation thing, if not for my ability to, discharge to the grid during the middle of the day. So, it was interesting. I think we posed some new challenges for Southern California Edison. Not terribly expensive, and I think the benefit for you now, if you're going to do it, is a lot of people have done it now before you, and it should be pretty easy. I hope that answered your question.
Thank you, Chuck. We have another question for Orange County. I'm not sure if Terry is online with us, but the question is, is there other pretreatment for biogas for hydrogen sulfide removal prior to carbon media? I guess a technical question. Terry, can you respond to us?
It's my understanding, this is Keith Davidson, it's my understanding that there is no iron sponge, and that the carbon bed takes care of both the hydrogen sulfide and the siloxane. Well, Terry?
Answer to the first question, that whether we have the pretreatment system prior to the carbon, the answer is no. The only treatment that we have is the carbon.
Yes, thank you, Terry.
Okay.
Next question is There's a lot of technical questions about particulars of the actual system, the Codigestion system. So I guess we'll ask Eric for the why is the heat exchanger between catalyst necessary? I guess it's part of the emissions cleanup.
Yeah, it's an interesting question, but it's quite an elegant solution when you're trying to use achieve both CO and NOx emission control with a three-way catalyst. Keith, are you online? I was actually going to ask some support from Keith Davidson on this particular question. In essence, they're able to achieve both CO and NOx control with basically reducing the temperature of the air prior to polishing to get the NOx removal. If you have too high a temperature, you basically are generating NOx at the same time as you're processing it. So the Codigestion approach is basically to cool the gas with the intermediate heat exchanger to achieve the end result. And it's quite an elegant solution, and it's very simple. It's made us kind of excited about how this can be used.
Yeah, if I could just maybe add a couple of words. After the first goes through the first stage catalyst, some air is injected so that the second stage catalyst can serve as basically an oxidation catalyst. So it oxidizes the VOCs and the CO. And if the temperature going in, the exhaust in the presence of air is too high, you're going to get more NOx formulation, as you said, Eric. And so by lowering the temperature, you're in a zone where the oxidation process takes place and you don't get NOx reformation. So that's the key.
Thank you. Next question, I guess, is for Grant Mack. And it asks, are there potential opportunities for water district to sell generation by bidding into California utility requests for offers? I believe you covered that in your first slide. And again, we will share the slide decks with everyone. And then the rest of this question, Grant, is there are technical solicitations that are usually not familiar to water districts. And the rest of it is just asking how technical assistance can help water district with submitting the bids. Again, we're here to help you technically, and please reach out to us if you have some kind of technical design questions. We'll be happy to address them, and my information is available on a slide. So at this time, we ran over by a few minutes. We're 11:05, and I want to basically tell everyone that we will review some other technical questions and get back to you individually. And I really want to ask everyone to please respond to the evaluation that you will receive after this webinar. We're looking to put on another webinar. Today's webinar was very wide in audience, so we covered a lot of topics, but if you're interested in something a lot more particular, especially based on the questions, maybe we can do a follow-up webinar and really get into interconnection issues or power purchase agreements. As you saw, Chuck was really adamant about the fact that for smaller plants, for example, you have small staff that have core competencies in doing a lot of other things, so letting some folks run your plant with a PPA, he's a big proponent of that, and if that is of interest, please let us know. And we're going to go ahead and wrap it up. I want to thank California Energy Commission and our speakers today. Thank you everybody for joining us, and please reach out to us. Here's my contact information. We do look forward to engaging with you to make your next CHP project a huge success. So with that, we'll close, and thank you everyone. Bye-bye.